So you can see that the error says a parameterless default constructor or one matching the signature int64, which is a long, and system string value is required. So we need a long and a string as the two parameters to our entity. Okay, sounds interesting. I know we have an ID and a value, so it wants a long and a string. But if we go jump into entity, you'll notice that it's just int. It's not a long, it's not a 64-bit integer, it's a 32-bit integer. The string is the right second parameter that we have to the constructor here, but something's up with the ID. Why are these different? So the reality is when we were using Entity Framework Core, we're using a different ORM. It's mapping things differently. In fact, the driver that's underneath that's calling the SQL could be a different implementation than the one that I'm using with Dapper. So we have two ORMs and they could be using different SQL drivers underneath. So we have completely different call paths even though they're meeting the same interface. Yes, they're both SQLite and yes, they're both ORMs, but they can still have different behaviors, even though technically the queries are going to look the exact same. What I would like to do here, just to keep this demonstration going, is that we're actually going to change this to long, and on our base entity, we're going to change this to long. And I've already tried this, so the rest of the application already compiles just using longs, so not really a big deal to worry about here. But I just wanted to mention this because if you are working in a real code base, in a real big application, and something like this happens where someone's like, hey, we can just go ahead and swap this out because the interface is the same, and it's technically the same database. Not so fast, right? This is a good reason to have functional tests over things. As much as I love unit testing, some type of functional or integration tests that actually exercise the SQL calls will make a huge difference catching things like this.